Hey guys, Alina here from Chem 112. Today we're going to talk about Module 2, more specifically naming organic compounds with multiple functional groups. Before we begin looking at prioritization, we're actually going to look at the different types of functional groups. So first up are the hydrocarbons. You have alkanes, which end in -ane, and an example of this would be propane. Next, you have the alkenes, which end in -ene. An example would be ethylene. Finally, you have the alkynes, which have a suffix -ine, and an example would be acetylene. Next up, we have alcohols and ethers. So alcohols have an OL ending, or -ol. The first example is going to be ethylene glycol, which is commonly used in antifreeze and polyesters. Next, ethers have the ending oxy or -ane. They're commonly used in aerosols and refrigerants, and an example of this would be methoxyethane. Aldehydes and ketones are actually pretty similar, but aldehydes have their double bonded O on a terminal or end carbon, whereas ketones have their double bonded O on a carbon that is somewhere in the middle. So first we're going to look at aldehydes, and their naming ends in -al or -ol. So an example would be ethanol, IUPAC, or acetaldehyde, and it's commonly used in perfumes and rubber. Then we have propanone or acetone, which is commonly used in cosmetics or plastic solvents. Carboxylic acids and esters. So carboxylic acids have an oic ending, and an example of this would be methanoic acid, or commonly known as formic acid. It's actually used as a preservative and also as an antibacterial agent. Next up, we have the esters. Their naming ends in -il and -oate. So an example would be ethyl propanoate. So now we're going to look at amines and amides, which are quite interesting actually. So amines end in amine, and amides end in amide. So first up, we're going to look at amines. An example would be methylamine, and it is commonly used in insecticides and paint remover. Next up, amides. An example would be paracetamol, which is actually Tylenol. So this is going to be the last set of functional groups. First up, we have the alkyl halides, then thiols and arenes. So alkyl halides begin with halo. So this is actually an exception here, looking at chlorofluoromethane. It was commonly used in refrigerants in the past, but it is since known to cause ozone depletion, so it is not used anymore. Then we have thiols, which contain sulfur, and their naming has the suffix thiol. So an example would be methionine. It is actually a type of amino acid, and it prevents liver damage in the case of overdose of acetaminophen or Tylenol. So methylbenzene, toluene, is the example of our arene, and it is commonly used in paint solvents and thinners, and also in leather tanning. Okay guys, finally we have reached part 2, prioritizing. So how do we prioritize functional groups? So I'm going to go over the general continuum from highest priority to lowest priority. But here on actually in the middle, you can see the molecules and you'll see the names coming up now. So first up you have carboxylic acids, then esters, amides, aldehydes, ketones, alcohols, thiols, amines, ethers, sulfides, alkenes, alkynes, alkyl halides, alkanes. So now let's look at a few examples. All right, let's move on. So here you can see the first example molecule. I'm going to start looking at the chart from highest priority and slowly go down to lowest, and I'm just going to point out any of the functional groups that are present in the molecule. So first, let's see, carboxylic acids. Yes, it is present, and it is right here. So that's going to be first priority. Esters, no. No amides, no aldehydes, but we do have ketones, and there's a ketone right here, so that's going to be second priority. We don't have any alcohols, no thiols, amines. There's an amine right here, third priority. Ethers, there's an ether right here, that is fourth priority. Moving down, sulfides, alkenes, alkynes, we have an alkyl halide, bromine, right here. And it's going to be fifth and final priority. So what are we going to do now? We've identified the main chain, so it's going to be a carboxylic acid. So everything that I highlight now is going to be a substituent. So we're going to look at the first carbon, second, third, and fourth. And the final name is going to be 4-bromo 2-methoxyamino 3-oxybutyric acid. For our second example, we're going to be looking at something a little more familiar, paracetamol or Tylenol. And we're going to look at the IUPAC name because this is not proper IUPAC nomenclature. So let's look at the functional groups highest to lowest priority. No carboxylic acids, no esters, but there is an amide and it is right here. So that is going to be first priority. Looking down the priority continuum, none of these functional groups are in the molecule. But there is one that isn't listed. This right here is a phenol, and it looks kind of like this. So this is going to be the substituent, and it actually falls below amides in the priority list. So this molecule, paracetamol, is going to be an amide. So second priority, and this is going to be the substituent. Final IUPAC name. Looking at the carbons, this is going to be N,4-hydroxyphenyl ethane amide. We're going to wrap this up with applications of functional groups in the real world. So there's actually a relationship between functional groups and pharmacological activity. More specifically, there's a link between possible H-bonds and drug solubility, and it's influenced by something called a mechanism of action. We're going to look at its definition. It's defined as the biochemical interaction through which a substance produces its pharmacological effect. So, solubility is a factor that influences the mechanism of action. What does this mean? More hydrogen bonds in a molecule, or a greater possibility of hydrogens to bond to a carbon, means greater solubility and a more effective drug. So in this case, it will mean alkanes are more soluble than alkenes, which are more soluble than alkynes. So now let's look at DNA. It is full of different types of functional groups, such as carboxyl groups, sulfhydryl groups, carbonyl groups, and amino groups. These are all important factors in the formation of DNA and proteins. So functional groups actually might determine the polarity of biological molecules, and they also affect their acidity. So thanks for your attention, everyone. I hope this has been helpful and you've learned something about functional groups, prioritizing, and IUPAC nomenclature.